Good afternoon. We are going to have our exam 2 next week, next Wednesday, and check the Piazza for details for the location and time. Okay. So today we will start with the Jupyter Notebook example for text analysis. Then we will move to the object, which is going to be the last topic covered in this exam. So as in this class, we introduce this natural language toolkit NLTK. So we start with import the NLTK and NumPy, a couple of libraries. Then we are going to load a document, a Word document. Okay, contains some human rights. I think we have explained how to open a file. We spent one of the lecture on how to open the file. Okay, by using with open as, then you do not need to particularly worry about close the file. So after you open that, then you call my file.read. Basically, you load everything, and then you try to do the split line. Basically, you get line by lines. So basically, we will play the same trick as we did during the lecture. We were loading actually one piece of article, but then we chop them into line, sentence, and sentence. We treat each sentence as a document. Okay. So then if we try to take a close look, we will say the corpus actually is a string. Then docs will be a list because we are chopping line by line and store them as a list here. Okay. And we can see we have a 69 lines. Of course, here, let's pretend we have 69 different documents. And the doc itself we'll consider as a corpus. So there's a few concepts. We have term, right? Once you're chopping them into n-gram, you have terms, you have documents, you have corpus. The corpus is a collection of your documents. All right. So then the first step is try to get terms, try to do tokenize. Basically, of course, there's many ways to do this. Okay, one of the most simple ways to do that manually. You can try to split, basically using some string method to split them, or you can try to use the NLTK. They have a built-in the word tokenizer. Okay. The difference to use this naive way or the manual way or using the NLTK one is a different difference in handling the functions. Okay. So let me see if I, for example, if you look at here, there's some subtle difference here. You can see using the first naive or the first manual way, the X comma, as you can see, the comma will be part of the your tokens. Okay, but if you're using the NLTK, the tokenizer, you can see those commas will be separate. I mean, those very subtle difference. Okay, and so let me see what this part. Yeah, so we can also explicitly to remove those punctuation if we do not need them. Okay. And after doing, I think that we by the way, everybody still remember how all the things we have been taught for the list comprehension is what exactly this sentence try to do, right? I hope you, although we won't test it in exam 2, but I hope you still remember what those sentences try to do. Okay. Any questions so far? Any questions about in understanding the procedure here? We are loading a piece of document. We chop them into sentence. Then we can either using string building method to chop them into word by word, or you can call the tokenizer building in the LTK toolbox. And the difference is the software in handling, for example, punctuation. Okay. After, if you are able to separate out all the commas and full stop, you can also doing some things as simple as like the one I highlighted, try to remove those punctuation. Okay. And then another thing is try to make everything into lowercase, right? And also remove the stop words. So as I mentioned, the stop words, I remember last day class, someone asked, do you consider can is a stop words? I mean, this is really, there's no super clear answer. It really depends. But good things is somebody defined a stop words in this toolbox here. So as long as you import these stop words, then you can know, okay, what are those words in English? Commonly, we consider them as stop words. Okay. Then again, we're using some kind of list comprehension, doing things, make things into lowercase, and also if things in a stop words list, we will not include them. Okay. And the next step is lemmaization and stamp. For example, the example we provide during the class is studies, studying. Those things, word-wise, they are different, but we know they probably means a very similar idea. Okay, so if we're using stamp, we will chop them into things like study, right? But the problem is the simple-minded lemmaization probably will create certain times create useless examples. For example, like important, right? If we chop it, it will become import. It will become very different. Those are the examples we give in the lecture. I hope that gives you some basic idea why. Why stamping? Sorry, I'm talking. Probably I'm using the wrong word. Why stamping is stemming is not a good idea. So sometimes we need to use a more dictionary-based understanding about some language. Right? We know what will be the original form of each. When of different variant of representations. In the NLTK, we have both. We have a stammer, which is the simple case, the very brute force way to chop probably those extensions. Okay, and also we have a more sophisticated way. Is this lemmalyzer is built from word map. Basically, it will understand the studies, studying all come from study. Okay, so we understand the language. So then you can try out create stammer or to choose to get a lemmalyzer. Then again, use list comprehension. You can see we are able to reduce everything into its more unified or simplified forms. Okay. For example, here we give a few examples. You give a word. We define a function, and you give a word. Then we will try to say, hey, what is a stem version? What is a lemma version? Okay. For example, like stones, you'll get stone, stone. Like jokes, you'll get joke and joke. Okay. Of course, you can give more things like speak. The stem version of speak, speak. But when you say speaking, and then the spoken, okay, the stem version will be spoken, but lemma version will be speak. Looks like the lemma version is a little bit more advanced. Okay. And then we give even more examples. Then the next important topic is to how to find important terms inside a piece of document to represent the document. So the basic idea is you have a piece of document. You want to find what's the best effective representation of this, right? So we can show you can use the some kind of word representation. You list your word vocabulary and then you mark a couple of important words to say, hey, this is a few very important word from this piece of document. That become a very signature representation for that document. But then at the first place, how do you find those important words, right? So as I mentioned, you base on frequency. So you need to count two frequencies. One is called term frequency. You need to count how many times the term appeared in a document. But that is not sufficient to say those words are important for this document. At the same time, you also need to see how less frequent this word will be used in other documents. Okay, so only when you measure both, you are able to say those most important words in this document. Okay, to do that, we need to, if you remember those examples we put in the lecture, we need to build some kind of word document matrix. Okay, so basically, let's say column wise, maybe documents, words. I mean, this is not particularly important, but anyway, one dimension will be document, one dimension will be words. Then you just try to counting the raw frequency there. Okay, from there you can derive your both the term frequency and the inverse document frequency. Okay, so this is the first one give a very intuitive way how to build the document word matrix. This actually is very simple. I don't know if I need to really talk about this. So basically, you first try to see how many words you have, and then you try to construct some kind of matrix here. So then just try to go through those go through those word list, and then basically to do the count for each document. So you can, I believe we have or we will release those examples on the course webpage. Just go to read. This is just some kind of very simple coding to say how to build this word document matrix. Okay, and then yeah, you will get something like this. I believe we have seen those examples during the lecture. Yeah, this is just to give you some examples how, if you want to write in Python, how do you code it? Okay, of course, another more efficient way to use this is try to use this emulator. I think that I mentioned this emulator during the very early stage of the class. So when you call the enumerator, it will try to output the element of a list into two things, into a index and also the element. So basically, you will also have an index for that. Yeah. Then you just with this you can say, for example, here you are doing the numpy 0. Basically, you create a matrix of zeros inside, which will be a document word. Then you will try to go through. Then the zip is another thing I think that I mentioned before. The zip is basically if you have multiple lists, it will try to aggregate them and iterate over them. Yeah. So I encourage you to, yes, questions. Which one? Which first line? This one? Yeah, that one. Yes, yes. Is that like Yeah, yes, very good, very good. This actually create a dictionary. Yeah, this is a create a dictionary. Perfect. Yeah. So I'm glad you see that. Yeah. So go back to read those examples. Yeah. Excellent. This is actually is using the emulator create a dictionary. So go back to read those examples. I'm sure you now you are able to read those codes, and if you're curious, you can type copy paste into a Jupyter notebook and try it out. But if you have any questions, do probably you can send me emails or come to my office hour. I can explain more. Yeah. Otherwise, let me move to the last topic. Sorry. Yes, let me. So I want to make sure I can finish this the last topic as soon, so you have time to review. Yeah. Okay. This lecture is about objects and classes. So Python is a object-oriented programming. Okay, we sometimes in short call it OOP language. This is very similar to like C++ or Java. If you have learned language or any object-oriented language like a Java, a lot of concepts we are going to introduce here will be very easy to be captured, to be caught. Yeah. So, but if this is your first time to hear object-oriented this concept, I will try to make sure to deliver this concept. But do ask me questions. Yeah. Because this is if you understand this OOP concept, is a very simple concept. But if you really get confused, then this can become a very confusing. Yeah. So please do raise questions during the lecture if you find some places it's so confusing. Okay. So object in Python is an abstraction for data, and so it usually our object will capture a bunch of actions and data. Okay. So we can say everything in Python is an object. All data is represented by objects or relations between objects. This even includes simple things like integer and floats. They are all modeled as objects. So every functions are special objects in Python. So this is explains why you can do so many. We have so much flexibility in handling functions. Okay. And usually for the OOP language, we will have a lot of cool properties like inheritance, polymorphism, abstraction. Yeah, we will come to those part. I think that it will spread over the rest of the semester. So even we haven't explicitly to mention this OOP concept, actually we have keep using it. When you build, let's say a regression model, we start with creating a regression object. Then we call the regression.fit or something. Those things is actually is a kind of we have already familiar with them. Yeah. But now we just try to make them more formalized. We make things more explicit to say what are they. So every object in Python has a identity. So identity is just like a name, right? And this name is a kind of unique, which in computer, of course, in computer system, the name usually will associate it as a memory address, right? Some kind of like a memory address. So you create an object, you have to allocate in your computer memory. So you have some numbers to to address this is that unique object. Okay, and also we have a type. The type usually when you say, hey, this object is belong to this type, then we will know what data you have, what actions you can be involved, and so on. Yeah, and values. So usually the values defines what the current state or the content stored inside the object. So those are the pretty straightforward, right? And some of those objects can be changed, like mutable. We call mutable. Some objects cannot be changed. Just think about list and tuple. They mutable or immutable. They are designed based on our needs. Right? Some application require different objects, different type of objects. For example, here we have a integer. We have a list, then we define a function, then we define a class, then from the class, we create an object. I will talk about what is class next, okay? So now, what I want to show in this example is we are trying to, using this to print out the ID and type. As you can see, this will be the output. So we have here, sorry. So yeah, as you can see, we have what happens here. We have a ID, we have type. Okay. So those IDs is a string of numbers. Just think them as some kind of memory address. All right. So after we briefly know what an object might look like, so how to define our object? So to define our object, we need to first define a class. A class is one of the, in my understanding, is one of the key concept to understand for any object-oriented language. Okay. A class, you can think them as a feeding blank sheet or a template, a blueprint. It's like you want to construct a house, you want to get a blueprint. So the class will give you basically define what this object roughly looks like. Okay, but the class itself is not yet has any concrete form yet. It's more abstract level. It just say, hey, this is how an object need to be look like. Then from the class, you can instantiate your actual object. From the same class, you can create many copies of object, actually as many copies of object. So each object you create from the class, the object itself is the concrete stuff you will play with. Because once you have the object, then you can concretely say, hey, where it is in your memory, right? And what it can do, so like what functions this object can do, and what it has, what values you are stored for inside that object. Okay, so the object will have this, but the class is an abstract form. The class doesn't have any much things. Okay, object will be an instance. It's like you are feeding the template. You're feeding the template with the actual things. Then you get instance of a class. So, any questions about, or does this cause any confusion or any curiosity about what is class, what is object? I hope you get a very brief. If you are new, I know a lot of you probably already know what is object-oriented programming. But for people who if this is the first time for you, please do stop me to raise questions. Okay. And yeah. because this is actually is a concept I learned, I don't know, maybe more than 20 years ago. So I already kind of forgot what confusion you may have at the beginning. So please do stop. And then, for example, I give an example. This is a class. The class although you have field method, but this is a more abstract. You won't really use them until you are create instance from the object. You say, okay, from this class, I can create one object. I don't know what happens. Yeah. So I can create another object. All right. For those objects, you can start to feeding the actual values, as you can see. Okay. So then once you create kind of instance from the classes, then you are able to start to use those objects. Yeah. And also most of the toolbox today, for example, in the machine learning community, we try to define something we call API, which is try to give you a basic idea. When you write a module, like what function you need to have, basically to define some kind of abstract specification. The purpose or the advantage of this is you can write let's say another module which can be seamlessly plugged into the existing toolbox. Right? If you remember, we have C, the regression model, and probably another I forgot. They all have the fit, right? They all say regression.fit something, right? So it looks like in there probably is required if you create a classifier or create a regressor, you would like to using the fit to invoke a training procedure, something like that. Yeah. So this API other time will give you a definition to say. So people will all be have no problem to use as long as you contribute as part of this toolbox. Okay. So now we are talking about how to create a instance of the object, or sometimes we call instantiating objects from classes. Okay. So you create class, which is your template, is a kind of feeding blank form. You try to feeding the blank, then you will get your own object. But you will have two things for an object. At least the two main things is what you need to define what actions you can invoke, like what action operations I can provide for an object, and also what data is inside object. So basically, this will be variable and method. All right. So this will be the two type of class attribute. You need to, when you define a class, you need to have this variable and method. Then from there, you can start to initiate instantiating objects. Okay. And there's another default function called init. It's a special constructor. The constructor is what is constructor? Constructor is when you create an object from a class. The constructor will be the first function it will get involved. Basically, it's like a constructing this object. Right? Think constructor as a special function to be called first when you are starting creating an object. Okay, so now let's see some concrete example. I think that those to better understand what are they. So now we define a class. All right. So remember those keywords: class, full, column, and then we say x equal to 7. Pay attention. I don't know how to emphasize here, but I want to emphasize here. Somehow I want to say, pay attention to this x equal to 7. This is a definition happens outside any functions. All right. And try to, I'm not sure why my slide today is automatically jumping. try to compare with what? Try to compare with another variable which defined inside a function. So before that, I want to re-emphasize, okay, this is a init, this is a constructor, right? As I mentioned, this is a special constructor. You have to, this is something which will be called when a new object is be created. So in the init, you have two parameters. This function takes two parameters. One is self, one is I. The self is how to say, when you define the class, usually the first parameter will be self. That means you pass this object self to this function. Okay. And the I will be the actual parameter. So the I will be some parameter when you provide, when you create an object from the foo. Okay. And as you can see here, once you provide the I will try to make the self dot y equal to I. That means I want to make this self is referred to this object. Of course, at the moment, there's no such object yet. But once you create this object, the self will refer to that object. Okay. And that object will have a variable dot y. I will initialize that with I. Okay. So now, as beginning, I won't say, please pay attention to this x. The x difference between x and y, there's a huge difference between x and y. Okay, so this is important. X doesn't associate with any object. So x is belong to this class. So x is a class variable. Okay. And the y here, y belong to an object. Is an object. So this is an object variable. All right. Or sometimes we call it an instance variable. So it's belong to a piece of particular object. The difference is if I create many copies of the instance from this class, they will all share the same x, but each of them will have a different y. So this is a key difference. Okay. So I think that this is I still remember this can be a very difficult concept if you, this is the first time you are doing this class object stuff. Okay. So class variable will be shared across all copies of the object, but this instance variable will associate with each object. They can, so basically they can, each object can hold a different value of x, but they have to have the same value for, they will have to have one global x. All right. Any questions about this part? Yes. Sorry? You can, but then that will make things a little bit. So when you write when you use a class object, class variable, obviously that for a purpose, right? If you each time you create a one, you reinitialized it, and maybe sometimes it's possible, but I will say double check, like what is your purpose? What's the purpose for that? Yeah. So for example, you can, when you create a new object, you can, let's say, increase that count, that x by 1. So this, at least this is a good purpose. That means you can count how many objects actually have created from this class, right? But if you override it, then I don't know. Yeah. So if you reinitialize it, then probably it's a little bit not very useful. Maybe useful. I just don't know. Yeah. And then we'll try to create another function inside the class. Okay. This class is try to, again, as you can see, I have the first parameter as self. That means I will take the self object. The self is, if you are C++ or Java user, the self is almost identical to like this. Yeah. So it's like you are passing the self into the master. Then you here we try to adding this instance variable and the global variable or the class variable together. Okay. And so now let's see how we can define some object. We will try to create one object, create another object. Okay. As you can see now the object taking a parameter here, right? As you can see, why taking a one parameter? Why it not taking two parameter or three? The reason is because when you create an object, it will try to follow the format you define in your constructor here. As you can see in the constructor, let me quit this. I don't know why this keep jumping. Let me reopen. All right. So the reason it use foo1, like using this format, is because this is defined by your init function, your constructor. You can see your constructor actually taking two parameters, right? Self and then I. But usually the self is only when you define a class. When you actually call the function, you will drop the self parameter. So which you will only have one left. Okay. Any questions about why we have a foo1? Any question about this? This is a following defined here. Okay. Yeah, please do feel free to stop me if you have any questions. Okay. And also again the foo2 is I don't understand why. The foo2 is try to passing a parameter 2, which is basically you are assigning a value to I. So when you do foo1, you will say I equal to 1, so your self y will equal to 1. When you do foo2, you will have another object. The other object will have y equal to 2. All right, okay. And both of them will share the same x equal to 7. So the difference here. So basically, after you do this, you will have one object which have x equal to 7, y equal to 1. Then you have another, you do the second, you have another object which have x equal to 7, but y equal to 2. And these two objects will locate in a different memory locations. They are complete two differences. They are like a two piece of object inside your memory. Okay, but they are created following the same template, which is defined in your class. I hope this make your class concept to be more clear. Okay. So now if you print the bar, because remember we have a bar function. So we have object A in your memory, we have object B probably in a very different location but they all have the same action, which is a bar. Bar essentially will return your current X and plus your current Y. All right. So both of them, they will share X, but have different Y. So which is reason they'll print two different values. The first A bar will equal to 8. B bar will equal to 9. Okay. Any questions why we have different values here? Looks like this slide is really can't wait. So, okay. Are we fine with the class and object one? Yes.
Is it possible to put the input variable inside of the class? Like, can you go back to the previous slide?
Okay.
So can you put the input variable for the definition bar
then that will become a more method, a method function. Yeah. So it will not. You probably you need to put inside the init. Yeah. Because if you put in the bar, I don't know how to initialize them. Yeah. You can, of course, you can create new variables inside the bar. That's no problem. Yeah. Then if you create a new object inside the bar, probably the scope of that will be within that function. So now we will try to talking about, actually we will try to explain some of the mysterious behavior. I think that at the beginning of the class, I was, or at the beginning of the course, I would say, hey, there's a lot of mysterious behavior. Let's just take it for granted. So now we will open the box a little bit to see why we will get those. For example, at the beginning, I think the first example we try to make you be a little bit fascinated about Python is say, hey, if we can use the plus sign, right? If A and B, they are integer, they will do the arithmetic summation. But if A and B, they are list or strings, they what the different behavior they will take. So how to do that is actually is very simple. Is try to say, hey, if you are implement some kind of add function for that object, then you will put your actual action, your desired action, implement that inside your add. You can do that. The same thing for the length, right? You can length a list, right? You can length a string. But why you so magic, like so you put length, then it automatically give you what you like. So again, we will give examples next. We will showing you how to actually write your own like length or even the string. Remember, we can print the objects, right? You give me an object, we can print. Sometimes we print get not very useful things. Sometimes we get a very nice format. So this is again, there's some kind of default method. We can override the default method. For example, yeah, if we don't happy with the with what is coded there, I will try to show one example to say, okay, how about let's define a new class called multiple list. This is I mean, it's not there. It's something we try to make up. Okay. So this, yeah, apologize. This slide's a little bit out of format. Yeah. So, yeah, I still haven't figured out when you convert the keynote to this PowerPoint. A lot of weird behaviors. Yeah. So we have constructor, which is a constructor is what? Constructor is when you create an object. This will be the first thing you are going to call. Okay. So when you call a constructor, it will try to do one thing. It will try to initialize its instance variable called lists to be empty. Okay. So this looks like any multi-list object will contain at least one instance variable to maintain something. Okay. What is that? We need to figure out. Okay. But it try to initialize that into empty. If you create an empty multi-list, it will contain an empty list value. Okay. So then we will define a function called underscore add. No, this is a this will be a default function to override if you want to start to later to using something like this plus sign. Okay, as you can see later, the reason we write the class here, we want to show we are able to create many many list object, and we want to make this object to start to accept a plus sign operator. We want to create an object which you can plus. Basically, you see this is a arithmetic sign. We can say plus something. Right? So by implement that, you need to implement your own version of add. So this add will take self, which is again your object self, and then you are passing a parameter. This parameter will be what is come next, will be the things you follow after your plus. Okay. So basically the A, of course, from this example, the A will be some kind of list, right? So now we will see, hey, if you pass me a list, how can I handle that? I think I have 2 more minutes. So then I will try to say inside I will create another empty multi-list. Then I will copy it. Okay. Then I will try to append it. Then I will try to return it. So this looks like once you add anything, I will try to copy what you have inside your instance variable here. And then I will adding another list into my list. So you will basically get a list of lists. Then I will return that to you. All right. So then just bear with me 1 minute. I will stop there. So then you want to implement the length, right? Then you will reimplement the default __ length. What you do there is you try to go through your current list, and for each of them, you will count how many elements in each sublist, and then add them all. You will count the complete. Then in order to implement the print, you also need to redefine the string function. Okay, so I will go more details next time. Yeah, so see you.